Thank you, Lionel. Thank you. I haven't even spoken yet. I would like to thank the Congress chairs for inviting me to the event today and for giving me the opportunity of offering this contribution. I would like to also reiterate the general welcome to the City of Glasgow. You know, when you're registered for a conference and you're given an umbrella as a gift, you know you're in Scotland. I'm going to give this general overview of the challenges and opportunities in the field of sustainable energy, and we have already heard quite a bit about energy, so there are definitely synergies between the sectors here to be discussed. And there are potential unintended consequences in the escalation of some of the sectors. I'm speaking as a representative from the University of Glasgow. This is a picture of our old campus in the West End, but I would like to state that the City of Glasgow actually hosts 4 universities, so I'm just one of them. I'm going to say just a couple of words about what Glasgow and the University of Glasgow have already been doing to try and tackle climate change. I will then make a little connection between energy as a broad topic and net zero, which I'm sure is jargon you've all heard about. I will then say something about how we can try and reduce emissions from the energy sector, and I will then focus a little bit more on sustainable energy, which is not just any energy. And then finally, I will try and offer a link to power metallurgy. I'll put the glasses on because with age comes wisdom. The University of Glasgow has been taking the lead in tackling climate change. We were in 2014 the very first European university to commit to fully divest from the fossil fuels industry. And we completed the exercise last year by redirecting some £18 million of investment. In 2017, we endorsed the United Nations Sustainable Development Goals. In 2019, we were the first university in Scotland to declare a climate emergency. And then in 2020, we published the Glasgow Green, which is our strategy to tackle climate change. And we still keep 2030 as our target to achieve net zero carbon emissions. And we are very aware of the challenges of achieving that target, but one needs to have a target in order to start prompting significant trends. The picture in the background is reminding us that in November 2021, the City of Glasgow hosted COP26. That was an amazing event and an amazing opportunity to come together and discuss these top-down challenges that the world is facing. The picture on the left is a trend of the reduction in emissions across Scotland, with a little dot showing the target for Scotland. Scotland wants to achieve net zero by 2045, which is 5 years ahead of the rest of the UK and also of the majority of European countries, and that's primarily because it is hoped that there will be a considerable amount of space underground in the North Sea to host CO2. The emissions have been reduced by about 50% since 1990, but the challenge is now to keep going down with that curve. What about the relationship between energy and net zero? Well, let me first say something more about net zero. We have heard terms such as zero, net zero, but also negative net zero. They don't mean exactly the same, and they're very important, especially for the industries, to understand which one of these three they should be aiming for. Zero would correspond to when an operation, an activity, an industrial project is able to produce with zero emissions while in operation. Net zero means that point in time when the amount of emissions that we generate out of an activity are captured and stored somewhere. Negative net zero means that because we've been accumulating emissions over time, we have a backlog of emissions to deal with. We actually need to keep going beyond net zero. And we need to keep going beyond net zero and capture more than what we will be emitting after that point because of this legacy amount of emissions in the atmosphere. The Paris Agreement fixes temperature targets. We already know now that net zero will not be enough to achieve that temperature target. So unless we can go beyond net zero, we are already set with an important challenge. On the right-hand side, you see an IEA excerpt from their 2023 report showing how behind we are with effectively capturing and storing the CO2. The bar on the extreme right is where we should be with regards to certain scenarios that have been proposed to society, and the left-hand side bars are where we are today in terms of actual projects and committed funding. Still a way ahead to go. Let's focus on the UK now, for those of you who are less familiar with the status of emissions in this side of the world. This is emissions by so-called sectors, and you will see that energy supply is one of the sectors reported in the statistics, and you will see also that the energy sector trend has been going down in terms of emissions produced. So the energy supply is definitely not the lead contributor to emissions in the UK, and is definitely not in many other countries. Transport is, on the contrary, what continues to remain stubbornly ahead of the statistics. So it was interesting to listen to Adeline's presentation earlier on, talking about a positive transport trend when transport is increasing in demand. For us, it's exactly the opposite, because it tends to correspond to more energy requirement, and if that energy requirement is not clean, that corresponds to more emissions. I would say also, when artificial intelligence was mentioned, for us it's a threat in some ways, AI, because at every click of the button to prompt an AI activity or to prompt a video, there is probably 700 times the amount of energy requirement behind the scenes. And so again, if the energy is not clean, we're actually causing an increase in emissions. So it's very, very important to have meetings like these where we come together and we actually discuss synergies and collaboration to make sure that we don't cause unintended consequences along the way. You will notice that industry as a sector has actually been very successful in reducing the emissions, and this is where I hope that this audience will continue going forward. It's easy to speak about emissions, but we often have misunderstandings as to which emissions we're exactly talking about. Many of you will have heard nomenclature such as Scope 1, Scope 2, and Scope 3 emissions, where here I want to also add the difference between consumption-based and production-based emissions. Let's take these circles on the left and imagine the intersection part being the city of Glasgow. We are looking at the generation and consumption within the borders of the city, but also we are looking at the activities triggered outside of the city to support the city itself. And we are looking at the imports into the city and the exports from the city. Depending on what counts in what one reports, the total amounts of emissions will vary. And that's summarized on the in the diagram on the bottom right corner of the slide. How can we try and reduce emissions from energy? Well, first, I have a little paradigm here where we have an increasing trend of emissions in the world on the left and a decreasing trend of emissions for the UK on the right, as a function of the type of fuel that we've been using. What we see is that in the world, we are still really finding it difficult to reduce global emissions. In the UK, we've been making progress, and you probably are aware that as of last year, the UK stopped making electricity from coal, so the last power plant was closed. But we're still using oil, we are still using gas. Even if we don't produce our own, we are still importing it. In fact, you will know that we hardly have any refineries left in the UK, so even if we produce more oil from this country, we will still be exporting it for refinement, and then we would be importing at the cost of the international market. So there would be no immediate financial benefits in doing that. But here I say, here I deny it. So that trend is important because also as Europe, we might be already successful in reducing emissions, but we have to deal with the world situation. We have to collaborate worldwide in order to collectively bring down those emissions. Let me now get into the discussions about reducing emissions from energy, incrementing the penetration of the renewables in society. The first slide is about power, and we always have to distinguish between power, i.e. electricity, let's say, and heating and cooling. Heating and cooling is also a very important requirement of our industries. We require not only power as source, but also very often high temperature or super high temperature processes. That is an energy requirement. How much of the power worldwide so far is coming from renewables? Not much. And between 2011 and 2021, the increase was only about 8%. So it's happening. We're already feeding the world with a good amount of renewable energy, power-wise, but we need to keep going. In the world, we're also realistic as to where we should be. On the right, you have a projection of where we should be actually nearly tomorrow, 2030, and the pathway is still hard to be followed and to be achieved. Still in electricity, but talking about Scotland, Scotland has been extremely successful thanks to its amazing wind resources, primarily onshore wind, and then over the last decade or so, offshore has been taking off exponentially. Something to watch out for, however, is the so-called curtailment. We are at a point where even if we wanted to bring on more wind, we actually have our grid networks already saturated. We have to debottleneck the grid networks in order to be able to feed them with more intermittent electricity from wind. It is projected that UK taxpayers will start spending about £1 billion in curtailment. That's the money that has to be paid to the wind operators to ask them not to produce wind electricity when there is wind. And this is a very critical point. On the right top, the bar charts are representing the quantity of renewable power produced in Scotland over time. 2025 obviously is yet to be completed, so we don't have all the quarters of the year. But what you will see is that we seem to have stabilized. So we seem to struggle to do more, to continue that exponential growth. And this is, again, the challenge of tomorrow, of today and tomorrow. And finally, we have achieved the initial target of average grams of CO2 equivalent emitted per unit energy in power, and we need to make sure that we maintain it or that we go even further down. You might be aware of the European green taxonomy. After Brexit, the UK has had its own choice to adopt a UK green taxonomy. One of the main discussions is that in the UK, the electricity is very clean, and so we would like to achieve and to establish even more ambitious emissions targets just for the UK. What about heat? I mentioned that heat is certainly a requirement for industries and for manufacturing processes. It's definitely also a requirement for domestic uses. Heat is actually the largest single source of carbon emissions in Scotland and in many other European countries. It's often overlooked. Often the statistics focus on power only, but please, please don't forget heating and cooling as well. And we really need to decarbonize that provision for both industries and domestic applications. At the moment in Scotland, we are primarily using bioenergy sources for that decarbonization. We need to increment and accelerate the use of heat pumps of any sort and look at other additional solutions. This slide is reminding us also of the global geopolitical urgencies and whether energy is enough in our countries, individual regions, but also Europe and other geographical locations. At the moment in the UK, we are clearly a net importer. And apart from a little moment when there was also the boom of oil and gas, we're likely to remain net importers. This is very important in terms of energy imports, but also in terms of the imports of the raw materials that are so essential to increment the penetration of the renewables. It's easier said than done that we can do lots and lots of solar or other renewables in a region of the world when, however, those renewables depend on critical raw materials that are coming from faraway countries, and where they're probably still mined and extracted in non-sustainable, non-ethical ways. So again, unintended consequences is something always key for us in sustainable energy conversations. You may have noticed that my statistics haven't so far introduced hydrogen. That's for two obvious reasons. One is that hydrogen is actually not a source of energy unless it is the natural hydrogen found in the subsurface, naturally in the subsurface, but that's only very few locations of the world. Otherwise, hydrogen is a storage solution. It's a storage carrier, an energy carrier. And the second reason why I haven't included hydrogen in renewable statistics is that there is actually a very clear unintended consequence of hydrogen, and that's its indirect global warming potential, GWP. Hydrogen itself is not a primary greenhouse gas, but when combined in the atmosphere with other gases such as methane, which we've been releasing in the atmosphere for many, many years, then it can become a potent indirect greenhouse gas. And recent studies produced in the UK, in the world, have demonstrated that the indirect GWP of hydrogen is about 100 times more, 100% more than what originally thought. And there will be emissions of hydrogen inevitably for all our transport distribution lines, as we have known for decades of operation of gas lines. Well, this talk is really about sustainable energy, and I would like to therefore step into discussions on sustainable net zero. Is it all just about emissions, or should we be considering other sustainability criteria? We're not starting from scratch. We already can leverage suggestions and definitions by organizations like the United Nations. The UN already told us that sustainable energy needs to meet 3 requirements, i.e. that the fuel should not significantly deplete itself by continuous use, that sustainable energy should not cause significant pollution or hazards to humans, ecology, and climate systems, and obviously we don't want to perpetuate social injustice. The definitions of Sustainable Development Goal 7 regarding energy say that we should be ensuring access to affordable, reliable, sustainable, and modern energy for all, and not just for a few privileged citizens of society or a few privileged countries. We don't have to start from scratch on this because we have very highly reputable reports out there already, including a few I'm sharing with you today, but there is more. The first one is from the World Bank. It's about building resilience based on a number of pillars on the right-hand side and indicators. For example, I could say, is your country a country which is already considering facilitating and promoting off-grid solutions? Does it already have an energy plan, a sustainable energy plan, and so on? We also have the World Energy Council that has been using for many years now the triangle of energy sustainability, so produces every year a ranking of countries based on how they're doing with regards to those 3 sustainability aspects. In addition, we have energy indicators from the IAEA and more. But just to be a little bit practical, I'm giving you just 2 examples of sustainability indicators. Many people believe that sustainability is just a buzzword, but actually you can quantify sustainability. And as I said, it's beyond just emissions. For example, you're starting a new energy project, and that could be an energy project that will then feed your new data server, that will then feed artificial intelligence. Well, how much land is that new energy project going to occupy? We live in a world where we see a lot of competition for land uses. Am I taking away land that could otherwise be used for agricultural purposes in a developing country? So here we go, there are already indicators for land use. Or I could also be asking myself the question, how many new jobs is your proposed energy project going to be creating? And in addition, I should also be asking myself the question, are those jobs going to be local, by the way? We know very well the partially successful story of wind in this country. The local job content of wind in the UK has struggled to go above 30%, meaning that the know-how, the technology is actually coming from outside, and with that go the jobs. And also, how long-term are those jobs? Very often in the news we read, oh, company such and such is going to start this amazing new energy project that will create, I don't know, 200 new jobs. Full stop. What it doesn't say is that those jobs will probably be there just during the construction period of 1 or 2 years and then will be gone. or will be replaced by jobs filled in by non-local content. So there are many indicators that we should be starting to use. The sustainability standards were mentioned in one of the previous slides. We have an international sustainability standards board that keeps on increasing the definition of these sustainability criteria. So to conclude, I would just like to bridge two challenges and opportunities in power metallurgy. Some of them have already been mentioned. As challenges, I would like to highlight what I said before, that there is a raw materials requirement, so we have to think about the sustainability of the full supply chain and apply life cycle analysis to understand from the start to the end where the materials are coming from, and also decommissioning and disposal of materials. I come originally from the oil and gas sector, and we have already learned our lessons that often decommissioned rigs have ended up in parts of the world where they've been decommissioned in totally unethical ways and non-sustainable ways from an environmental perspective. So we don't want to repeat what we have already learned. We want to make sure that we deal with the full supply chain responsibly. Energy consumption is still high, so we need to think about the energy requirement for the processes that PMs and materials demand, and what is the quantity of the energy requirement, but also what is the quality. Where is your energy coming from? Are you able to decarbonize the energy source? Could you even consider building a new bespoke dedicated energy supply project just for your manufacturing processes? Could you join forces with other businesses to create that new cleaner energy provision? Opportunities, obviously, increasing the energy efficiency of the manufacturing processes, increasing the renewable electricity contribution to manufacturing processes, and as it has already been mentioned, there is certainly an increase in demand of PMs for renewable energy components. That would be for the wind turbines and also for the solar batteries, among others. So with this, I conclude my talk with a thank you, and I also wish you a very successful and productive rest of the event. Thank you.